Course 3, here's a pretty important lesson. 41 is about functions, and it's going to be challenging too, mostly because you haven't learned a lot about functions. You've learned how to do the work that's going to be necessary today. They've set you up well, but you haven't used the word function much, and they're not going to get deep in it, but it could get a little confusing, and it's kind of a longer lesson, so we'll do what we can, and I imagine we might do some of this in class too. You know formulas such as perimeter of a square is 4 times one of its sides, right? S stands for side, P stands for perimeter. But the formula is really what we could call a function because it's sort of like a machine. And when you put in an S, it spits out a P. Just like when you put in a carrot into a juicer. Alright, this is my carrot. And there's like a juice machine here or something like that. I put in a carrot, but I don't get exactly a carrot back. I get juice in my glass. Carrot juice or something. Okay, now think of the carrot as the X or the input. And the juicer is the function. The juice is the Y that comes out, called the output. Okay? So I stick in my carrot for S, and it spits out juice, or the Y, the output. Alright? Kind of making sense? One of my better illustrations for once. We'll take it. They've got a nice picture of a machine here. You put in your X, you come out with a Y. You come in with your 1 for an S. Right? If a side is 1, then the perimeter is 4. You can graph these pretty easily. If you think of this as X and this is Y. Okay? 1 for X and 1, 2, 3, 4 for Y puts me at 1, 4 is my first point, right? And then we put in 2 for S. And you have to do it. You can't just think you can do it from looking at this because then you get confused. Stick the 2 in there, do 2 times 4, and you get 8. Alright, and then graph that on the table. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That's 2, 8, and it'll keep going up like this. Notice it goes in a nice straight line. When it's in a straight line, we call it proportional or linear. I do a similar problem in example 1. Let's move on past it to example 2. Xavier and Yolanda play a game where he thinks of a number. Yolanda performs a regular, consistent operation, whatever that may be, we don't know, and spits out a Y, a new number. Xavier says 2, Yolanda says 4, Xavier says 3, Yolanda says 5, and so on. You might see some pattern going on, right? Every time Xavier says a number, Yolanda adds 2. Yolanda's number is Xavier's plus 2. Alright, and you can graph this with a T-chart. You stick in a 1 and you get 3. You stick in a 2 and you get 4. Right? You can graph these points. 1, 3, 2, 4. Let's see what it looks like on the next page. Once again, very linear. It's in a line. It's straight. They say it's not proportional, though. The ratio of output to input is not constant in this case. Even though it came out linear, sorry about that. Should have looked at this a little closer. It's not proportional because if you look at 3 over 1, that does not equal 4 over 2. They are not all equal the way that 3 over 1 is the same as 6 over 2 is the same as 9 over 3. Proportional but not equal. The function is linear. The points are aligned with the origin. Oh, sorry, the points are not aligned with the origin, and that means it's not proportional. It needs to go through 0 to be proportional. So let's see if that original one that I said was, I think it is. Yeah, that one was. It went through 0. Went through the origin. This is a good one to be familiar with. Area of a square. Pretty much any formula, any area formula is a function. Area is side squared, right? The rule with words means that you take a side and you square it to find A. You can do a t-chart, right? If you do 0, then you're going to have 0 for an area. 1 is 1, but then it starts to really take off and the gap between numbers increases, it accelerates, because when you have a square, you usually don't end up with a straight line. You get this curving line, which is kind of interesting. We're able to graph it because they chose small numbers. It's not linear because it's not a straight line. In this case, they do have a proportional numbers game because it goes through 0, right? Is what we learned together. If you want to graph the function y is 1/2 x minus 2, just make a table, an x and y table. Put in, 1 for x means half minus 2 would be negative 1/2, right? Put in 4, and you get 2 minus 2 is 0. Let's try putting in a negative number and see what happens. Oops. Pardon me. Let's try negative 4. Gives me a negative 2 minus 2. This is why we learned how to subtract integers. If you put in negative 2, you get a negative 4. And if we start to graph this, I can just imagine it's going to be like a 1, negative 1/2, 4, 0, negative 2, negative 4. It's going to look like this kind of. Let's see what they did on page 283 here. They used 0, 1, 2. No. There we go. They used 0, 2, and 4, kind of like mine, and yep, the line looks the same. Notice that no matter what numbers you choose, the relationship ensures that your answer will still be right. There's no correct choice for x. Okay? Alright, so you got a sense of functions, how we graph them, and now you know what it means. Proportional not only means it has to be a linear function, but it has to go through the origin. It can't cross the y in other places. Let's do B, D, and G. Do your best to ask questions.